Hello everybody, I just wanted to give you a quick update on where I'm at with my first past the post game and turning it into a browser playable game. So the first biggest challenge that I had when I wanted to make this game was how on earth do I get around to making this board? I knew how I wanted it to work, but obviously I couldn't sit there and type all of this JSON. And it took me quite a while to come up with a reasonable plan for actually putting out all of the layouts that I wanted. And I did this here with a slightly weird system, but I could choose. I had to prepare some of it in JSON before I started, and then I could start putting the bits on the board I wanted. This probably won't look very good. I can't remember how exactly I did it, but I could choose some kind of layout. Say I wanted cities here. Now this is not going to look like a very good England, especially because Londonderry's in Ireland. But and then I would go through afterwards and say, well, I want all the cities. I want a city here, and city here, and then because you can't really save stuff very well from the browser, I created this output JSON button so I could copy and paste that into a file that I was going to use, which was better than trying to write it all by JSON, like by hand, because that was going to take me forever to pre-calculate. So I definitely think this was the right way to handle that. And once I'd kind of made this system, I actually hardly changed it when I moved to writing the board for the game file. It's basically the same code that draws the board, but I have the place where I put the function calls to the board are actually outside of the board. So, or at least the bits that handle the mouse clicking are done outside the board and tell the board what to do. So the board it's simply a thing that can display stuff and store a certain amount, but it doesn't do anything. It just can be told how it should look and what it should store. So here's how the game actually plays. First thing I need to do is to choose a hex or region that I want to campaign for. So say for example I choose to campaign for this region here. I can then choose what budget I'm going to give for that region. I'll give it 30, and yellow clearly gave it 41. They put the most campaigning there, they got the most sway in that area. They now win that region, and you can tell because they've got the circle in the corner there. And this hex has turned yellow, this city hex square. That's to show that yellow has control of this constituency right now. But that can of course be taken away if someone else competes for it slightly better. So wow, yellow is winning everything. Now the cards are dealt out at random, and actually currently the computer chooses its moves at random, so this is purely luck that yellow has got the most so far. And we're going for this one here, and this one's gone to blue. So blue now has this city because he's won this region, but we can probably take it back this turn. I'm going to go for this. If I put 45 here, that's probably the most. No, 46, green has won it. Now if you see, green has control of this region because green has the city hex, and the city hex is kind of a tiebreaker. So if they both have the same number of regions, the city hex contains more people because cities have more people than rural spaces for the same area. And so green currently has control of that, but if blue gets another region, then that would win it back. So I want to try and take control of this region. Let's yeah, well, I don't think we're going to get it back. Player 2 won that, so that's yellow. Green. And because a small town, that's what this circle, and that's a large town, has slightly more people than a completely rural hex, green currently has control of this. Though in general I find the city wins it. It is possible for the small town to to change things if, say for example, green got this one, but red got this one, and yellow got this one. Then it would be dependent on the small town to answer the large town who would win that constituency. As you can see, we've actually got counting working as well. So we've got two cities have gone to green and 2 cities have gone to yellow. So that's good. It helps to just to keep track of all the things that are going on. And it's currently green's turn by the look of things. So green has chosen this hex for us to play for. I don't have any budget, so yellow now has the city, but we can win them back. I'll try and I'll try and get. I'm not going to get this one. He's hoping yellow doesn't get it, because of course, if you want to win a region, right? Blue and yellow are competing for there. I can take this. Maybe, probably. No, player 2 wins. That's green. So this one is an open region. It's actually still possible for me to win this. Who got that? Blue with 48. So I think it's unlikely that I'm going to win this. I need to win both of those. And I might be better off directing my campaign budget in a different direction. So I've got 44 here. I can choose this one. If I... Actually, let's go here. This one, it's impossible to take back right now. This square becomes basically irrelevant. Oh no, green won that. I will be introducing the action cards soon, which will change things. So you can end up gaining sway and you can end up gerrymandering. So I'm going to talk a bit about how I've actually built this project. Obviously it's written in JavaScript. I had some fun trying to throw it together, initially writing the board code. One of my first struggles was dependencies. I wanted to be able to find where in my code any problems were, and as you can see, like when this is called, it tells me it happened in Canvas.js line 10. But if I'd compiled this, the code, the JavaScript, using something else, I would lose this positional information about where the problem was. And I didn't want it all in a single file. And I did want to be able to get that kind of information, at least for now. Maybe when I actually release it, I'll probably throw it into a single file that is all of those files thrown together. But what I did to achieve this in the end was I wrote a method. So if we open up play.js, I could write in here dep, short for dependency. So this depends on other code. And of course, some of those codes that I depend on might depend on other code. So if I open up layout rowcall.js, you see this one depends on layout.js. And so by putting these dependencies like this, I could then write a script, and that script is called jsdep. And that would take a file. So if I open up playgen.html, playgen.html, this is actually a Golang template. So it looks like a HTML file, and then it's got in the middle of it these squiggly braces which work in Golang when it runs its template things, and calls this jsdep function on the file play.js, which had all of these dependencies, and finds them. So if I was to type jsdep, which is the name of the function, dab template, and play.js, so no, it's not. The template is play. gen.html, and then it outputs the HTML, but now you see it has play.js is the last one, and everything it's dependent on is above it. Now, some of the challenge I had trying to write that was making sure that the one above, so if one of these depended on something else but I found them earlier, so I actually have a kind of scan through each file and make sure all of the other dependencies, to make sure the ones, to make sure any files a file depends on come before it. That took a bit of fancy maths, but it was, I'm quite happy with the result. Obviously that means you can't have any cyclic dependencies, but you really shouldn't have cyclic dependencies anyway. And because that just outputs it like so, all I just need to do is point that into a file, and then when I open up play.html, I've got all of the dependencies I need. That means if I add a new file, I don't have to remember, I just need to make sure that means if I add a new dependency to one file, I don't need to think about the HTML, I just need to add the dependency to the file I'm working on, and it's a little bit less thinky. If you want to have a look at JSDep, you can get it from my GitHub. It is at github.com/codeconvoy/JSDep. I haven't written a license, but feel free to use it, just don't sue me. Another fun challenge I had when writing this, aside from getting the board together and all of that working out which hexes can talk to which hexes and making sure gerrymandering worked. It's just simply the layout problem, and I had some fun with that. Trying to make sure it fit appropriately in whichever shape I hold it so it works okay on people's phones. And that was done using the layouts. Basically every layout has to have two methods. They have a draw method, which takes a context, a width and a height. So I decided that the width and the height was something that was going to change so often that I'd rather just pass that down as a parameter from the layout container to the object. But because you actually have a translate method on the context, I didn't need to pass down its width, its X and Y position within that. I could just translate and draw appropriately for that. And again, for the get XY, it takes a width and height parameter as well as a mouse X and Y, which is relative to the object, and then it can find the appropriate child if it has multiple children, or if it doesn't have any children, then it will return itself. These two methods are basically the core of how the layouts work. So any function can find the appropriate child through these mechanisms. So all layouts we're going to have a children array, so I just threw that in like so. So the way I actually get it to switch mode when I reach a certain width for the canvas is by having this base ratio swapper, which just stores a ratio, and if the width over the height is greater than the ratio, it draws an internal layout. Otherwise it draws another layout, and one of those layouts is a width layout, and the other is, one of those layouts is the wide layout, and one of those is a high layout. And I have this ratio swapper layout here, which just inputs an A and a B. And then in rowcall, layout rowcall.js, I had a function which created a rowcall layout, a function called rowcall layout, which actually returns a ratio swapper layout where it's created a row layout and a column layout as its children. So it makes the row layout if it's a certain width, and so this is why it takes the ratio as a thing. It creates this, and I changed its add method just because you can do that in JavaScript to anytime you gave it a child and its fractional width on frac A and frac B, and that could actually of course just be one parameter, because JavaScript allows for you to just ignore a parameter. And I could add its fractional A and its fraction on B to each of the children. And that meant, although it is technically a ratio swapper layout, I don't have to worry about knowing that a ratio swapper layout is how it works. I just know I've got a row call layout that does what I need. I can add, and possibly later I'll add a remove method to the row call layout and not worry about it. For now I don't need it. There. Back to the board. If we read through this, you'll see that I don't actually have any mouse methods on the board or any actions that it really does. The board is kind of something that other things act on. It does have methods, and it has a draw method, which probably took the most of the work in this, that and the calculate method. But if we go to play.js and so qtest, I probably should actually change that to editor.js, but this is where it uses the same board, right? It depends on board. And here it sets the mouse down method on the board to actually be a change, and whenever you click on it, it gets you information about the squares. Whereas the play one, it actually has its own mouse methods, and it sets it gives the board a different set of mouse actions. So hopefully you found this interesting. Maybe you're a little excited to see the game actually finished. If you are, feel free to like and subscribe to this, or even make a pull request on Coded Convoy on github.com, Coded Convoy, and then it's FPTP JS. So first past the post, JavaScript. And feel free, again, there's no license. I probably need to put a license in this one, but feel free to make a pull request, and that will help me to get it moving. Don't worry if you don't want to, I'll understand. My name is Matt Stoodley from storyfeet.com, and you have just watched a video.